Good afternoon, everybody. We will start our session, record session 3.1. We will discuss about the mobility in relation with technical session, and this is will focus on how we can do discuss about the various issue in relation with the development of low carbon vehicle and how we can do support with related infrastructure in relation to achieve the low carbon vehicle. The topic is the challenge of decarbonizing mobility. And first, I would like to introduce to all. I'm Ahmad Safrudin from Maskeei, Indonesian Society for Conservation and Efficiency Energy. Especially, I was head of the mobility working group, sustainable mobility working group. And of course, we are happy here. We have Mr. Agus Tjahajana from Indonesia Electric Vehicle Battery Development Project. Mr. Agus Tjahajana will share to us in relation about the challenge and prospect of developing electric vehicle battery manufacturing in Indonesia. And secondly, we have my old friend, Anup Bandivadekar, from International Council on Clean Transportation. Mr. Anup will share to us about lesson learned from decarbonization on transportation project. And that we have biofuel for transportation issue, and how far can you go? This subtopic will be delivered by Mr. Kukuh Kumara, also my old friend from Indonesia Automotive Industry Association, or GAIKINDO. And then we also have Mr. Rajesh Saha, Mr. Rajesh Saha, Regional Sales and Marketing Head, Asia Pacific for Rail Electric Vehicle Fast Charging with integration, Hitachi ABB Power Grid. And fifth, we also have Mr. Barman Tambunan from BPPT, especially on the Energy Conversion Technology Division. Mr. Barman Tambunan will share to us about the universal electric vehicle charging technology. Okay, as we know, that's actually on the electric vehicle almost 6 years after we have a conference in Paris in 2015, and then we know any agreement, we call it as a Paris Agreement. And after that, how we can to implement the Paris Agreement in relation with to achieve the low carbon in all of sector. In relation with the subsector of transportation, of course, we need to discuss how we can to achieve low carbon development, low carbon transportation, or in another word, like a low carbon mobility. So, of course, for that we need technical aspect in relation to implement that all that has been agreed in the Paris Agreement. Of course, we hope that we can have input or initiative from this discussion, and then we can bring it to the field to implement in relation to achieve the low carbon mobility. For the first, I would like to invite Mr. Agus Tjahajana to share about the challenge and prospect of developing electric vehicle battery manufacturing in Indonesia. Time for yours, Mr. Agus Tjahajana. Suaranya masih di mute.
Ya.
Siap.
My presentation is in English, but may I speak in Bahasa?
It's okay. We have a translator, Agus.
Okay. So for me, it's more convenient in the presentation.
That's great.
Okay. Let me upload first my presentations. Mana sih? Share screen ya. Udah. File saya. Advance. Apa yang harus dibuka dulu kali ya? Ada. Wow. Gimana nih? Nah, kirim aja. Sorry, I have a problem to upload my file. Let me stop.
Probably our technician can support us. Can help Agus.
Yeah, udah kirim. I already sent to you. The committee, please upload.
Okay.
Ini kan dicoba tuh susah. Udah? Udah dikasih? Halo, may I speak to the committee, please?
Siap,
Ya,
Pak.
Bapak.
I will help you, Pak Agus.
Udah di-upload, Bu?
Sudah dapat, Pak. Kami sudah buka,
Ya.
sedang buka nih, Pak ya. Sebentar.
Oke.
Ya, Pak.
Oke. Kenapa ya nggak bisa? Saya nggak rubah ini sih, biasanya pakai yang ini nih. Share screen. No. Nggak ada.
Halo, Pak Kukuh. How are you?
Makasih, Pak Bubut,
Sama-sama.
Mas Bubut. Iya.
Siap. Pak Barman. Sehat, Pak ya?
Alhamdulillah sehat, baik.
Alhamdulillah sehat semuanya.
Ya.
Apa kabar, Pak? Terima kasih, Pak.
Kabar baik, Pak. Mr. Rajesh, how are you? Yes, okay. Everything okay? We were still any technical.
Yeah, fine. I'm okay.
Oh, great. That's great. And we also have Mr. Anup Bandivadekar, probably now in the early morning in San Francisco.
Bisa nggak dia? Apa maaf ini harus yang PPT? PDF juga bisa kan?
Kias kapan Pak Kukuh?
Yes, kalau rencananya mudah-mudahan COVID-nya ini menurun. Ini trennya juga bikin ketar-ketir. Rencananya sih tanggal 12 Agustus di Jakarta. Ya.
Di Jakarta ya. Virtual atau offline?
Offline. tapi dengan ketat. Nah, ini udah tampil.
Oke, siap.
Agus,
Oke, please Pak Agus, time is yours.
Okay, so thank you very much for the occasions. I would like to present my presentations in two languages. Sometimes I'm using Bahasa and sometimes I'm using English. So because for me it's more convenient, but of course my presentation is in English. So to whom who speak English very fluent, I think they still understand my presentations. Please, next. So my presentation will cover 5 topics. First, about the background, Indonesia. The second is about Indonesia opportunity, and it's a blur. I cannot read. Okay, and competitive advantage. The third, development of Indonesia EV battery ecosystem. 4, challenge for EV battery industry development, and I will close my presentations with some remarks. Next. First, the background. So I believe, as already everybody aware, that Indonesia is already one of the member. Please, next. The member of the Paris Agreement. So we are committed to make it successful. Yeah. For Indonesia right now, for our company, that we see that one of the reasons why we are developing the EV battery, because we understand that one of the reasons the CO2 is very high is because of the land transportations. In my presentation, we can see that one car can produce 1.1 tons of CO2 in 19,000 kilometers. So how to reduce it? Of course, we understand that we have to go to newly EV, yeah. So next. We understand also that according to the many estimate or calculations in 2040, that the supply and demand of BEV and also ICE will, we can see in this slide, that BEV will become 58% in 2040, and ICE will reduce only to about 42%. And there will be a big demand for battery in the world, that we see that more than 1,000 gigawatt hours probably we can supply to the world consumptions if we can produce the EV battery to supply the electric vehicles. Next. We understand also that there are some technology in EV battery. From the 6 that I put this in the slide, I believe that our company will take the NCM configurations with the red flag in on the right hand side of my presentations. So the NCM is nickel, cobalt, and manganese. Why is this so? Yeah, next. Yeah, because we understand that nickel will be one of the base of the future battery element for the EV. We understand that for the time being, that our vehicle in Indonesia for BEV is still very low, but world will become more and more aggressive, increasing. So we understand that in order to produce EV battery, we have to export as well as to take care of the domestic demand. Next. So that is the situations of the EV battery business in the world. So what is the opportunity and competitiveness, competitive advantage of Indonesia? Next. Indonesia is considered very low in the density of the car. Now, our statistics show is only less than 100 for 1,000 people. So, if we compare with other countries as well in Southeast Asia, our market will still far developed and compete with every country in the region. And then we understand that one of the basic component of the EV is the battery. So battery, in my slide, can be seen that will cost about 35% of the car cost. So that the reason why this is one of the reason we actually decide to develop the EV battery, the battery for EV in Indonesia. And we are very lucky, then we are blessing that we have very big nickel ores in our country, #1 in the world. Yeah. So in the future, the battery will go to the nickel technology. Indonesia is a sort of country which are very rich with the nickel. So these situations is very promising for Indonesia to set up this company. Yeah. Next. So the team make some calculations about what is the demand for Indonesia. So there are two scenarios, in low case and best case. And our team decide to use the best case as the backbone for the calculation for the company's calculations for the profitability of the company. So here in 2035, at least in our calculation, about 30 gigawatt hours will be available in the market in domestic. About from those 19 for wheel, and then 5 gigawatt for two wheels, and other is for energy storage, and the rest I believe that we can export. Yeah. So that is the prospect. So this is the way we develop the we call it Indonesia EV battery ecosystem or battery industry. So there are 3 scenarios we are going to take forward for the future. That first, we are going to be a global upstream players in the battery materials. And then second, we are going to be a global midstream player in cathode materials. And the third, of course, we are hoping we can become regional and domestic downstream players in the battery for EV as well as for XEV. So this is the strategic thinkings of our company. Yeah. As I already explained that Indonesia has a very very large deposit of nickel, number one in the world. We also have several other materials such copper and any other material that probably can strengthen the competitiveness of the company. Next. So this is the model that we are being developed. So we are going to produce the from the very upstream in the ore, and then we are processing up to nickel sulfate, and then to precursor, cathode, and then up to the cell. This is the four company that that will be involved in the battery company. So the shareholders, the owner is Antam, Mine ID, Pertamina, and PLN. So the name of the company who will produce the battery we call IBC, Indonesian Battery Corporations, and we are now is under talk with some partners to start the joint venture. Yeah. So this is actually the strategic investment that we are going to make up to 2030 from the very upstream to the downstream. So we call it end-to-end EV battery industry development plan. Next. So this is the partner that now we are being not recruiting, but try to get a partnership. Yeah. From the 11 partner, we try to select one or two companies that probably can be make a partnership with our company. Yeah.
2 minutes later, Agus.
Yeah.
2 minutes later.
Yes.
Okay, thank you.
So the roadmap is like this. We hope that in 2033 the HPAL can be start to produce their product, and then 2024 we can start produce more downstream product. Yeah. Yeah. Well, that is the progress, and also, but what is the challenge? I think this is I only have one slide since the time is very limited. Yeah, please, next. Yeah, we have several obstacles that probably we have to solve. Yeah, about the technology, about the partner, about the regulations, and everything that we have to deal and then to solve one by one. But we understand that we can solve it one by one, and I hope that the company can start the productions at least 2024, as I explained. Yeah. Now what? Next. Next. Okay. I think this is my last slide. So we hope that if we can make it happen, that Indonesia can get the benefit, that we can create at least 24 billion US dollars in GDP. We also can create 23,000 people additional new jobs, and also the export is about 9 billion US dollar per year. So thank you very much for the occasions. I hope that my presentations can give you some insight about what is the situations right now in Indonesia in the area of energy efficiency and also conservation that you all taking care of. Thank you very much.
Thank you, Pak Agus, for the excellent presentation. And we know that's any sharing from Pak Agus that's first about the global trend in relation with the ICE technology and also EV technology, and secondly about the technology of electric vehicle battery, and then the third about national projection on vehicle sales and also population, and the fourth about the competitive advantage what Indonesia have, especially on the nickel cobalt mining as natural resources. That's probably this is a competitive advantage in the future. And Bagus also share about the prospect of electric vehicle battery, and on the other hand, Bagus also share in relation to looking for investment partner. I think that's all from Bagus. And the next we invite Dr. Anup Bandivadekar from ICCT. You have 10 or 12 minutes to share this, please.
Thank you, Kukuh, for the introduction. For those of you who don't know, I work with the International Council on Clean Transportation. We are a small not-for-profit research organization based with colleagues on now totaling over 120 in different parts of the world. We really focus on reducing air pollution and greenhouse gas emissions from all modes of transportation. I lead our passenger vehicle program around the world, but I've got colleagues who focus on heavy-duty vehicles, trucks, buses, airplanes, ships, and all the fuels that go with them. Back and look at the challenge in terms of meeting what Kukuh introduced at the beginning as the goals of the Paris Accord in terms of getting to 1.5 degrees or below in terms of global climate temperature increase. This is the current projection, pre-COVID of course, of annual CO2 emissions from global transportation sector. And that shows that current trajectory is roughly on track to double between now and 2050. Even if you take into account all the measures that have been incorporated in the first place. A lot of that is passenger vehicles, but the heavy-duty vehicle share, around 30% today, is now increasing quite rapidly. Where the growth is going to take place in the coming 3 decades, a lot of it is going to be in Asia. China, of course, is a major one, but other Asia Pacific, India, are really big growth areas, as well as global sectors of marine and aviation, where a lot of this growth is going to take place. And so the challenge really for us is to take that upward sloping curve that we saw 2 slides ago and bend it relatively quickly and bend it sharply enough going down into the future. As you see from here, our sort of current trajectory is about 12 gigatons of CO2 emissions in 2020, projected to go up to 21 gigatons, and our target by around 2050 is in the range of something like 3 or so gigatons of carbon. So it's a pretty major take, and that's the reason for this increased emphasis and focus on electric mobility, because it seems to be the only pathway that could actually get us there in the limited time that we have in front of us. let me say a little bit more as to why that is the case. So as our analysis showed that from our current level of emissions globally, emissions will keep on rising because of growth happening in economy around the world, light duty vehicles, heavy duty vehicles, aviation, marine, some black carbon emissions growing. And so the pathways to getting them down are going to be through a combination of zero emission vehicles on light duty and heavy duty side, and efficiency and emissions increases, as well as improving our compliance and enforcement practices. But what we find is even if we do all of the above, that is, we do large-scale electrification, we do large-scale efficiency improvement in light duty, heavy duty, marine, aviation, use lower carbon fuels, particularly second-generation biofuels going forward, and we reduce black carbon emissions, we'll still require other transportation system emissions in order to actually achieve this kind of a goal. So it's a major change in the transportation sector that's necessary in the next 3 decades. And what are the policies that are getting us there? Let's really focus on the efficiency and zero emission vehicle components of these. This chart, some of you may have seen before. It shows the global passenger car CO2 emission standards normalized to the European values. And it's a spaghetti chart showing all the different countries around the world, regions around the world that have a CO2 performance standard for passenger cars. And right now, the EU has set a tight emission standards, roughly around 60 grams of CO2 per kilometer in 2030. And the talk is of making this even more stringent by 2030. But a whole variety of countries. The most important thing to note is that the chart is going from the upper left corner to the lower right corner, that it is downward sloping, and the slope in many cases seems to be getting a bit steeper over time. How are these standards really contributing to uptake of efficient and electric vehicles? Let me give you an example with a comparison of European Union and India. For as long as we've been tracking, all the way back from 2006-07 up to until recently, the CO2 emissions performance of new passenger cars in EU and India tracked close together very much. They were pretty neck and neck until about 2019. And then something changed in 2020, where the new passenger car performance of European vehicles dropped dramatically to 97 grams from 122 the year before, whereas India stayed at around 121 grams per kilometer. Well, what changed is that India's 2022 emission standards is only 110 grams per kilometer, whereas Europe had set a target for 95 grams per kilometer in 2020 and 2021. And what that really forced is the European manufacturers is to bring on electric vehicles in large numbers. So as you can see, in 2019, the new market share of plug-in hybrid and electric vehicles was only about 3% in 2019. By the time we got to 2020, that market share nearly quadrupled from 3% all the way to 11% and so. And in fact, in the month of December 2020, we saw nearly 1 in every 4 cars sold in the European Union was an electric drive. So these regulatory standards play a major role in electrifying vehicles. So that's an important lesson. What's more is that more and more countries are now setting standards that are more of a mandate on manufacturers to produce a certain fraction of their new vehicle sales be electric drive. In cases of China, California, British Columbia, these are regulated standards. In other cases, they are targets where there are combinations of hybrids and plug-in hybrids and EVs. And in some cases, these CO2 standards are stringent enough that we expect to force more than 30% electrification to happen in places like the European Union. And what's really enabling that is this massive reduction in battery costs that by now all of us are quite familiar with. But it's still quite astounding to think that over the last decade, new lithium-ion battery prices have come down by nearly 90%. And they're not done reducing the prices. Prices are expected to fall further down to $100 per kilowatt hour or less by 2024, and projected to continue to go down, perhaps halving from the present levels by 2030 timeframe. So quite a big change in battery prices. And that's encouraging regulators, in this case, California, to think about electrification of not just light vehicles like two-wheelers and cars, but also heavy vehicles, trucks in particular. And so California has now put in place a zero-emission truck requirement that a fixed percentage of new vehicle sales of trucks have to be electric drive, and even the largest, the class 7-8 tractor trailers sold in California, 40% of them have to be electric drive by 2035. And for the smaller trucks, even larger share of electrification is expected through these regulations. So that's not happening in a vacuum. This is a chart that is showing zero emission trucks are coming to the market in US, in EU, in China, where these regulatory actions are proceeding. You can see that they are a wide range of them for different types of applications, heavy, medium, cargo, yard tractors, and others, and a whole different ranges of electric range, all the way from 100 kilometers to very large trucks capable of traveling well over 1,000 kilometers. And all these models are going to come to market between now and essentially 2 years from now. Let me switch gears really quickly and give you an example on why this kind of a change is likely across the board, from these heavy trucks down all the way down to passenger vehicles and light duty vehicles, including two-wheelers. This is an analysis that we've done for India to evaluate what are the conventional technology efficiency improvements that are possible. And we find that actually ICE technology can become energy efficient by quite a lot. In fact, motorcycles in India, which are quite efficient, could become another 40% more efficient through a combination of really known technologies. The same thing applies to scooters. Again, very well-known technologies, some very simple technologies, and some requiring a bit advanced technology, such as hybridization. But that can get 40% reduction in what we already consider to be efficient vehicles. But where the dynamics is changing is that already the electric two-wheelers are cost effective, even compared with very high efficiency two-wheelers at low range costs. So what this chart is showing is a 100-kilometer range motorcycle without any fiscal incentives from the government will actually be cost effective in terms of total cost of ownership by 2022 timeframe. Now, bigger electric vehicles with longer range will take several more years to be cost effective in terms of total cost of ownership. But of course, in all of the major markets, including India and Indonesia, is coming up with more financial incentive for electric two-wheelers. These total cost of ownership parity is expected to be reached a lot sooner. Similar numbers show up for scooters. In many cases, that parity is going to be reached even faster. And so while there are many, many cost-effective ICE technologies on two-wheeler front, the electric two-wheeler technologies are becoming equally or more attractive in the short term. Let me switch gears once again and talk about a different kind of vehicle segment, the ride-hailing platforms, so Uber and Grab kind of taxi platforms that are now available. So governments around the world are again requiring these ride-hailing platforms to be fully electrified in the next decade or so. And the type of policy intervention is quite different. In cases, particularly provinces in China, the local governments have put in place strategies for full electrification. In places like California, they're coming up with regulations on clean miles that the ride-hailing companies have to meet. In cities like London, the permitting requirements for ride-hailing vehicles depend on ride-hailing companies electrifying their fleets, and that is really encouraging a lot of action on part of these ride-hailing companies like Uber and Grab in Indonesia, but in those markets in US, Lyft, really moving forward in electrification front. Let me just present two additional pieces of evidence on viability of electric mobility, and then I'll close. One is this persistent question about, oh yeah, but aren't you just going to charge them with coal-fired power plants? And this is the life cycle analysis of electric vehicles produced today with other types of vehicles, including those who run on natural gas and combination of biogas, as well as fuel cell hydrogen made from renewables and natural gas pathways. And what we find that even with today's grid mix, with heavily coal-dependent grid mix, we get anywhere between 20 to 30% life cycle emission reduction. For a future vehicle, now this is a 2030 scenario, that emission reduction from electric vehicles is going to be even steeper in spite of the emissions pathway that countries' power grid will follow. And sure, the emission reductions are not really restricted to just greenhouse gas side. So we've done power plant by power plant evaluation and looked at air pollution impacts. And what we really see is that firstly, the power requirement from electric vehicles, when in a scenario where we assume nearly all of the new vehicles in India are electrified by mid-century, power requirement from EVs and the relative emissions coming from that in this goal are tiny by comparison to overall power sector emissions. And in fact, if we don't do this, the share of old on-road transport vehicles and air pollution impact will keep on rising quite dramatically. So let me just close by offering some pieces of high-level advice or suggestions for Indonesia. Based upon our global work, what we found is a five-pronged approach, really. Setting up a long-term zero-emission vehicle deployment target, whether it's 2035, 2040, 2050, whatever that is, being very clear about when that kind of a transition is expected. Setting up very stringent fuel efficiency standards and or a zero-emission vehicle mandates. Providing fiscal incentives, especially for the next 5 to 8 years time frame, are going to be necessary. And at the same time, investing in public charging infrastructure to a limited degree, essentially to improve public confidence in this technology. And lastly, but not the least, investing from right now onwards on consumer awareness, because that's one element we find even in the leading EV markets of the world that continues to be lacking going forward. So let me stop there, and if you've got time at the end, we'll take questions. Thank you.
Thank you very much, Dr. Anup, for excellent presentation. Yes, we have now that's the first you share about the global transport sector on CO2, and in your presentation we know that's business as usual will be any 12 gigaton CO2, and any effort to be cut off to be cut off 2.6 gigaton by 2050. And secondly, also you said about the baseline CO2 from transportation sector and how we can do also to improve the CO2 reduction performance in the future from the heavy duty vehicle, marine light duty vehicle, and also from low carbon fuel. And then also you said about the trend CO2 performance of passengers car, and in several countries, and like in EU, for instance, you share about the standard on the 60 gram CO2 per kilometer by 2030, like that. And of course, you have a great recommendation for Indonesia in relation to decarbonizing transport sector, and we know that's one of your recommendation about the fiscal policy. I think that's something that's very important in relation to trigger about the decarbonizing in transport sector. Again, thank you very much. And just introduce Dr. Anup. Actually, Dr. Anup has worked for Indonesia for a long time, at least since 2012. Dr. Anup assisted us in relation to improve the air quality, especially how we can to set up the policy in relation to adopt the lower emission vehicle. Okay, the next I would like to invite Pak Kukuh Kumara, the Secretary General of GAIKINDO, or Indonesia Automobile Industry Association. Pak Kukuh will share us about the biofuel for transportation. How far can you go? Please, Pak Kukuh.
Thank you, Mas Bubut, for having me in this discussion or seminar on the contribution of the automotive industry. And the question that you raise is that how far can you go? Yes, I think with respect to biofuel, I believe we can go as far as we want. But again, there are others alternatives that we need to make things happen. I would like to explain a little bit background about the automotive industry, and I think we have two main tasks on the automotive industry. On one side, as we discussed today, is that we want to reduce the emission, and on the other side, we have to be able to continue developing the industry, automotive industry, because its contribution to the Indonesian economy is relatively significant. Next. Yeah, this is the outline I would like to share. This is the why I mentioned about the two sides of main task. That the next, yes, that's correct. Next. Yeah, because contribution of the GDP is 3.9, and then total capacity currently 2.4. We haven't been able to utilize, and because of the pandemic, it's going down 29% utilization of the production capacity. There are about 1.5 million people are working in this in industry environment, and then our contribution to the export of non-oil is about 4.5%. We are sometimes we rank 8, we move to 4, and then down to 6, and so on. But again, this is emphasizing the importance of the industry. We have 42 members. Next. This is, you can see from the graphic, the up and down of the automotive industry since 72 until recently. A lot of issue affecting the automotive industry. But again, very important that the policy is also supporting the industry. And in 2013, I think we reached about 1.2 or 1.3 million production. And that time we are introducing what we call SCCC, low cost green car. And I think it's quite successful. There is a definition on that one. And right now, the LCGC car or KPH2 enjoying about 20% market share and has been maintained there quite from year to year. Next. So with the LCGC is also a part of effort to reduce the emission. This is the impact of the COVID-19. Usually we already produce and sales domestically about 1 million more. And then also the export of the CBU vehicles produced in Indonesia are reaching the highest number in 2019, which is about 330,000. But then because of the pandemic, is going down in 2020, only 230,000 units are exported. But then in January, May, we expecting that or we hope that the economy is recover and the industry is going back to normal. Next. This is, I think, illustrating the vehicles being produced. Mainly there are two types of fuel being used by vehicles produced in Indonesia. But 75% are using gasoline. That's why it's very important that we are able to come up with other alternative that can be reduce the dependency on the fossil fuel. And the other one, the green one, mostly are commercial, are using diesel fuel, about 24%, and others are relatively low, CNG and electric vehicle, as mentioned by Agus earlier, that we are moving toward the new or the zero emission vehicles. And we have a lot of resources that can support that development of the electric vehicle or what we call zero emission vehicles. Next. Just information also that basically in 2018 we are implementing a Euro 4 emission standard. And you can see this is the trend from 1975. We are moving towards zero emission, as I earlier mentioned. And in 2013, we introduced the LCGC, low cost green car, where number of item requirement is that the emission should be low and the fuel efficiency is also should be efficient. So, and also the price, I think, vehicles should be affordable for most people. That's why it's gaining its popularity. But we are moving toward the zero emission and 2015 and so on. And now we are trying to come up with other alternative hybrid vehicles and so on. Next. Basically, this is the map of progressing from of the industry, starting with importing CPU, moving toward the CKD and so on, and then with all local content and so on. But we are also have a responsibility to have reducing the emission. So hopefully by 2030, we should be able to come up with the vehicles have with the low emission vehicles. Next. this is one of the concern. We understand that, as I mentioned, one of the responsibility is to maintain the industry and also creating labor employment. So right now we have the installed capacity about 2.4 million unit of car per year, but so far when the pandemic hit, the utilization is down to 29. Even though during regular before the pandemic, the utilization is still relatively low, about 54%. So we need to utilize that one. And the question probably is next time whether we are going to continue mostly producing ICE vehicles, or we can also produce the zero emission vehicle with electric vehicle or other alternative like a hybrid, plug-in hybrid. And ultimately, if this is the solution, is the electric vehicles. Both the hybrid, plug-in hybrid can be built in Indonesia. And if the battery producer are able to produce and can be used, it can be beneficial for the industry, that we can utilize the capacity. So it's a matter of time when we can naturally shifting from a combination between ICE and EV or other option. Next.
1 minute more, Pak.
Okay, next, let's move quick. Move through. Next one. Next. Yes, next. Let's move to the. Yes, this is on the last. Our concentration is that we basically should use the alternative fuel in Indonesia, because Indonesia is an agricultural country. So we should have agricultural based fuel. Biodiesel, we already introduced since 2020 mandatory P30, but the ethanol has not been utilized so far, even though it has been introduced in 2006. And then CNG also we haven't heard progressing. The Transjakarta used to be using the CNG, but now we haven't seen back to diesel engine. And also we should be able to introduce multi-fuel vehicles. Technology for both fuel are readily available and relatively cheap. The automotive technology using both biodiesel gasoil is already available. The existing vehicle can use both fuel with minimal or without modification. I think BPPT has run these projects using PE, P10 and so on. So, but we haven't seen that much progress. Next. I think I just passed this one. This is just illustration. But again, the biofuel is not receiving attention so much like the other. So we need to introduce that one next. Next, I would like to pass this one. So this is a comparison. 75% is gasoline. If we use ethanol, then the contribution of reducing the emission is quite significant. And the diesel fuel, 24%, and we already introduced P30. I think we can stay with the P30. It's quite significant because moving to above P30 is a different matter. That's an issue of the oil company to produce according to the specification. Next. Here we also receive information that basically P100 is already being produced, even though the production capacity is still at the 20,000 barrel per day, but it can be improved and make it further. That's why we said that we can go as far as we want. Next. Next, just pass that one. So this is the alternative. I would like to pass this one. Mandatory P30 is already in January 2020. So summary, basically we can introduce biofuel both for diesel and as well as for gasoline. And if we can introduce for gasoline, it's going to be very significant because 75% of the four-wheelers are using gasoline. So it's significant. What the challenge and issue is basically we need to have consistency on policy and also the mass production and cost. And the fourth is the availability and distribution. And the last one I think is the socialization. So basically we can go that one. You can imagine if we can start with the E5 or E10, is there a lot of saving can be done. And then the vehicle technology on gas oil is readily available, so we don't have invest that much. And availability, continuous supply of gas oil is also important. And bioethanol is renewable fuel and produce low emission. So again, it's called on us right now. We have introduced bioethanol, biodiesel, bioethanol since 2006. But you can see the up and down. We haven't heard that much on this fuel. So the issue is on the availability of the fuel and the production of fuel. On the cost, yes, slightly higher because we compare the cost with the subsidized fuel. So sometimes it's very hard. And just for note, why we cannot use that one even right now, since 2016, even the aviation is already using the what they call SAF, sustainable aviation fuel, which is coming from the biofuel from the used cooking oil. With that, I would like to close because if aviation can use that one, I think the land transportation, we can use also the biofuel. Thank you very much.
Thank you, Pak Kukuh, for excellent presentation. We noted at least any 5 let's say notification. Like the first about you share about the fluctuation on the total sales of the motor vehicle in Indonesia. And then secondly, about the transitional policy on the decarbonizing transport sector through low carbon fuel like biodiesel and also bioethanol, as you mentioned in the presentation. The third about the progress on automobile policy and its impact on the total sales policy. It also include the low emission vehicle. And the fourth, that's any dropping of the total sales in 2020 because the pandemic effects. And fifth, needs to look for innovation to rise up the total demand of the motor vehicle. And I also share about the challenge and issue. And then lastly, recommend about the gasohol or ethanol, bioethanol in relation to the alternative for gasoline. Thank you again, Pak Kukuh. And next we will invite Mr. Rajesh Saha from Hitachi ABB Power Grid. 10 until 12 minutes because we have limited time. We must finalize at 3:30. Please, Mr. Rajesh.
Yeah, can you hear me now?
Yeah, great.
Okay. And you can see my screen as well, right?
Yeah.
Okay, it was really interesting to listen on the different perspectives which we had discussed today about how do we move ahead with adopting green mobility and then how we can keep our environment more clean and green. I think we have discussed a lot about the vehicle and the vehicle technology and battery and I think on the alternative fuel. I would like to touch upon something which is also a very critical part in going forward for electric mobility. that is about charging infrastructure, because it's like a chicken and egg story. So when you plan for a large amount of electric vehicle, then do we have a sufficient amount of charging infrastructure? And then how do we basically manage and plan so that we can basically cater to the needs of the future? Of course, when you plan a charging infrastructure, you are bringing something new in the system, which is not available now, and it will give some sort of challenges to the grid operator, for example, PLN and all those utilities. And we basically would like to discuss more on that part. So before that, I would like to give a brief introduction about our company where I am working. So it's a Hitachi ABB Power Grid, and we have basically journey started almost more than 100 years back in 1891, and we were made ABB in 1988, and from last year we are part of Hitachi with majority stake from Hitachi. So this is the Hitachi ABB Power Grid. That's all. Okay, since I was talking more about the power, because let's say our gene is on power, because we are dealing with a lot of high voltage and the grid connected systems. So when we think about a charging infrastructure, that means giving a power to a bus or any truck, we think not only about the module, we also think the impact and the load which will happen in the system, so that your overall system does not get collapsed because of the large amount of electric charger you are putting in one location. So we are working on different segments, for example, high voltage DC projects, also on power quality solution, semiconductors, services. So we have team in every country, including Indonesia, where we have basically a good amount of service people. I think when you discuss about the charging infrastructure, the service is very important part, because it is not about planning a charging and bringing a charger. It's also about long-term sustainability of the charger. I will discuss how it happens. Now let's say what happens. How do a normal operator or a normal bus operator or kind of a fleet operator plan? So they go for a pilot, and then they go for a trial, and then they go for a large scale e-mobility fleet. But when you see that when you are planning a scaling up an infrastructure for fleet, you need to also consider that it's not about putting some charger. You need to upgrade the grid connection. So the existing connection in the grid might not be sufficient for charging so many vehicles in one location. It also need to consider that when you are planning such a charging infrastructure for 40 or 50 electric buses or trucks, you may need to make a substation and some layout for the power infrastructure. So these are the few key things which needs to be planned in advance. And also then we need to plan this demand overnight from the cost and schedule perspective. To see the challenge faced in planning grid to plug, that means if you are planning from grid to chargers, one of the major challenges faced is footprint. Because if you see the chargers pleasantly located, they occupy a huge space in the depot, which is generally allocated for bus parking. So how to manage? Then all these charging systems mostly are located outdoors, and in the climatic condition like in Southeast Asia, where it is heavy rain, and so this power electronics in the field protection is really a big challenge. Third is the interface with the grid, power quality, and there are also a lot of grid code which needs to be confirmed before you plan a charging infrastructure. And then also the higher maintenance cost and the delays and for the grid and also the longer installation time. So what is the challenges in the depot? Is available power from the grid, space, monitoring to ensure next day start. Do you need to ensure vehicle preconditioning? Because if you are starting a bus, you may need to have a kind of air conditioning before, and then the reliability of the supply. So, and then there may be a possibility that your depot where you are putting 40, 50 chargers with so many cables and things maybe need to be moved in future. So all these aspects has to be planned for depot as well as if you are planning some charging in the route or the issues, for example, aesthetics and available power from the grid. So if you see the step thinking, how will infrastructure will grow with the fleet? Does the energy, we need to ask that questions to before planning. Does the energy provider plan to increase the connection capacity? How degraded nodes has been considered due to heavy traffic or any backup? Is the depot planned in the future? How to install and commission electrical infrastructure? If you see a charging strategy for different electric bus or truck, there are different strategies like overnight charging in the depot. There are opportunity charging in the terminal, that is end of the route. And then there is also flash charging. That means when you are traveling along the route, you can top up the battery in certain stops. This is very, very critical when you are have a BRT system and having a longer electric bus, because if you want to have a long electric bus, you need a large battery. And if you need large battery, capex goes very high. So in these cases, it is very important that you top up the batteries on the route. And I think these three strategies, we cannot say one is best. Every project we need to evaluate which one is best suited for you. Now let's see the portfolio, for example, what we cover. We cover all three types of charging strategies as Hitachi Power Grid, because we generally think that it has to be evaluated well advanced and with the grid planning. Maybe you need to have the grid study before we need to start. That's the reason we cover all three strategies when we are having a planning and electric charging infrastructure. So one, the name is given as flash. Here the bus, when the bus stops in the bus stop, within 30 seconds time, the bus charge, the charger charge a significant amount of the battery, only within 30 seconds of time. And we also cover the large scale electric vehicle charging and then also the battery power train. Of course, all this combination may be a perfect fit for any of the charging infrastructure requirements. If you see the experiences, what we would like to share here is that we had few project experience in Geneva where they had a plan to have a longer electric bus, but they did not have any space in the depot. So they wanted to charge the bus on the route, and that's how this project was conceptualized and delivered with 18-meter bus with 133 passengers. We are then, and in the bus stop, 600 kilowatt for 20 seconds flash charging is delivering a huge good amount of power for the bus to continue running. So this is one of the examples how a project in Geneva where the customer did not have enough space, they wanted to fit into the existing depot, was delivered, and it has solved many things for the client. For example, it has eased the charging system. They need not to increase the depot size. You can see such a small depot, and they are managing within the charging system in such a small space. And they can basically do the charging on the route. This is another similar project in France. You can see the bus. It's a bus manufactured by Hess, and this is a bi-articulated 24-meter bus. Here also that we had there was a challenge of the grid and the depot, and so the solution was given is to charge the bus on the route. This is very, very important for a BRT kind of project where you are planning a long buses like a train or light rail train, and this can really impact a major benefit.
1 minute more, please.
Okay. This is another project in Brisbane where similar train for 24-meter buses looks like it, from the metro LRT concept has been in plan. Now I would like to go for another concept of DC distribution. So here what is happening, if you see a normal charging system, they occupy a lot of space in the depot because they're putting the power electronics outdoor, and this space is basically for parking the bus. So when this address, and sometimes this bus driver may hit the charger located outside, which is quite expensive. So the plan, what to counter the challenges, how the solution has been worked out. The entire rectification from AC to DC is done in a container which is away from the electric bus, and then we only put some kind of charging pedestrians or plug near the bus. So that way the problem of space and then power electronics getting affected due to the climatic condition is solved, and also it saves lot of space and cost. So this is one of the very interesting solution which is we are offering, and to manage the challenges which is faced by the client. So it can save around 60% space, as well as it can save cabling up to 40%. So this comes in a container, and it can basically electrify 80 electric bus with just 2 40-feet containers. And you can basically park this container far from your charging area or your bus parking area, and this can really save the space for bus parking. This is a project in Milan which has been now using the same concept. You can see only this charging pedestrian near the bus. There is no big panel near the bus. So this depot is quite compact. Okay. We had tie-up with a lot of companies. This is the project in Milan with Solaris. This is the project with S, and in France, in Switzerland, and in France. So the last message I would like to give is that it's not very important only we plan chargers. It's also important that we look at the grid, we look at holistic view, we also look at the scalability, how to scale your charging infrastructure for the future. Then only the trust on electric mobility will remain. Otherwise, it will be we need to keep on changing our charging system. Then it may not be more suitable because CapEx will go high. So with all these aspects in mind, it is very important we plan from charger, grid to plug. So that is our key word to plan for grid to plug. Thank you.
Thank you very much for Mr. Rajesh for the excellent presentation. Yes, we have noted that the first in relation with decarbonizing transport, especially through the electric vehicle. It is very important to manage about the power supply and power grid. That's very essential in relation to manage for the power supply. And of course, in relation with the planning for infrastructure, we need to prepare for this power grid, and in relation to deliver to the charging system like that. So, okay, the next we still have Mr. Barman Tambunan, but we have limited time, just around 7 minutes remaining time before 3:30. So I hope Mr. Barman Tambunan can make a presentation for 5 or 7 minutes. So sorry for that. Okay, please, Pak Barman.
Yeah, hello. Thank you very much, Mr. Moderator. To the honorable ladies and gentlemen who were present this afternoon, I think I have to wrap up my presentation very quick because I only have 5 minutes. But anyway, I will try. I already distribute my presentation. Will you be able to help me to present my paper, my stuff? Yes, okay. Thank you very much. Okay, yeah, can you go to the next slide? Yes, okay. So actually, I will start with the question about the how are the prospects for implementation of electric vehicle in Indonesia. But again, I will focus actually on one things. Yeah, allow me to deliver to explain about the development of the charging station. Yeah, actually, I want to explain it, but I don't have time for all these points. But what I want to talk here is about the charging station that has been developed at BPPT, where the activity has been carried out since 2018. And just some introduction that our daily activities in BPPT, where I know is conducting testing, consulting, and technology services, as well also carrying out activities, engineering activities, which one of them is to develop the charging station. Yeah, next slide, please. The electric vehicle, electric vehicle ecosystem actually consists of many parts, like charging station, energy cells, batteries, components, plugs, standards, and so forth. If you refer to the presidential regulation, I've seen that it is necessary to make efforts to improve the ecosystems, which includes various things such as availability of the electricity, and then the charging station, the creation of the market, etc., etc. And the large implementation of the electric vehicles in several sectors, such as two-wheel vehicles, public transportation, e-mobility services, and also impacting on the reducing the air pollution. And BPPT has played a role in the ecosystem network and has participated in improving the electric vehicle ecosystem by conducting research development which focus on charging station, propulsion motors, batteries, and fixed review services, policy recommendation, and also increasing the local content. Next, please. In accordance with the 7 roles of BPPT, promulgated in Law Number 11 of 2019, concerning the National Science and Technology System, BPPT, in technology innovation of the charging station system, position itself in developing the charging station. BPPT applies the principle of capacity building as and many things. But next slide, please. Next slide. I think only 4 minutes. Okay. So I want to explain about the product and commercialization plan. Like what BPPT done. So BPPT is making a technology competence center. BPPT opens in collaboration with various related parties such as domestic industries, startups, universities, and other research and development institutions, and fast charging technology forum. And this forum is open but bound and restricted. Activities include training, workshop, joint development, lab scale testing, etc. The result of automat can vary, ranging from standards and regulation. Next, please. This is the development of the ecosystem of the electric vehicle, which was built by BPPT together with several parties. Let's see here the inauguration of the charging station, and focus group discussion welcoming the electric vehicle in era in the era about 17th of July, and then it's come with the presidential decree number 55, and then active vehicle exhibition on confined Ministry of Transportation, two-wheel fast charging development. Yeah, we start in 2019. Four-wheel fast charging development and cooperation with Pertamina Patra to run the 2 charging stations which currently is installed, cooperation with BPPT. Next slide, please. Yeah. So this year we focus on being able to produce prototype fast charging station for two-wheel, and prototype fast charging station of four-wheel electric vehicles with the name of Sonic AC with the technology level of 6, and then prototyping rapid charging station for four-wheel electric vehicles with the name of Sonic DC, as well as the charging station management system application called Sonic with technology readiness level of 7. And in addition, a study of business model and cooperation in the field of implementing the charging station in collaboration with PT Pertamina. Next slide, please. Yeah, the following is the timeline activities where we go through here for the fast charging station for wheel, 22 kW kilowatt. The prototype has been developed since last year, currently in the process of testing. And for the DC of 50 kilowatt for wheels charging station, the prototype design was only developed this year. Last year, two-wheel charging station succeeded in making the first stage prototype, and the charging station monitorization application itself is the earliest prototype that was successfully designed last year because it is in the form of software and it's still operating today. Currently being upgraded and designed mobile user application version based on Android and iOS. Next year, the plan will be upgrading again in order to support the latest technology. Next. Yeah, as mentioned earlier, the further development in coming years will focus on the increasing the local content, domestic component level to support the increase of used domestic product. I think I will go to the next slide because I have to explain many things in here, but yeah. So this is the following of the result of the development of fast charging station for the two-wheel electric vehicles. It's currently being developed a prototype fast charging station for the second stage wheel with the name Sonic R2, which has 2 outlets. The payment system uses multi-payments such as smart cards, QRIS, and mobile application. And fast charging is claimed to be able to save up to 50% charging time for the electric motorcycles. Next. Yeah, the following is the charging station for four wheels, a fast charging prototype with a capacity of 22 kilowatt of alternating current and has been developed with the name of Sonic AC. The AC fast charging prototype is currently in the process of testing and downstreaming. At the same time, DC rapid charging station prototype with a capacity of 50 kilowatt direct current is being developed named Sonic DC. And the target this year is only for assembling and component testing. Next. Yeah, here is some specification for the AC fast charging station that we developed. The output is 3 fast alternating current, 220 volt. The plug uses a type of 2 AC plug. It supports the OCP version 1.6G protocol and supports 4G LTE cellular communication. Next. Yeah, this is also the DC rapid charging station of 50 kilowatt. I think I have to go quick because I think my time running now. Next. Yeah, this is the following the human machine interface designed using a touch layer for the charging station unit, where currently a payment system using a smart card NFC has been developed but has not been integrated with the bank. So it is only support closed loop systems, and later, in addition to being integrated with bank's payment system, will also be developed using a mobile application.
Second, Barman, please.
Okay, I will go directly to my latest slide, or I will, yeah. So next. I think next. Yeah, this is the latest. Yeah, this is the before. Yeah. Okay, this. So maybe my conclusion as it is that first. The need for the number of charging stations will become very important by the falling number of the car developments. BPPT has developed several models for the needs of charging stations, both for the two-wheel and four-wheel. We focus efforts for the development of domestic industry so that we are able to build this charging station industrial ecosystem. We also currently develop charging station monitoring software, which will be also be partnered with state-owned companies in order to strengthen the charging station system. And the latest is we really hopes for support from all parties who can take part in the development of this charging station together with BPPT. Okay, thank you very much.
Thank you, Pak Barman.
So quick time.
Okay, so I apologize for that, Pak Barman, but that's very excellent presentation. That's also very important in relation to develop the ecosystem of the electric vehicle in Indonesia. That's about the power supply, charging, fast charging system, and also another supporting techniques like electric vehicle car workshop, something like that. And thank you very much for the presentation again, Pak Barman. And I think we must finalize this session. Again, apologize that we have not enough time to make a discussion. But of course, for the participant, if you have a question, comment, or another, you can share to our link and IC link and our email, and then we can deliver to all of our related speaker, and then we will provide the feedback from the speaker in the link of the IC website. I think we must finalize this session, but I will give you a chance, probably 30 seconds, if a speaker to give the closing remark. Please, from Dr. Anup, 30 seconds to closing statement, please.
So we heard both sort of opportunities, challenges on a variety of different aspects. What I would state here is that it's much more necessary for us to focus on setting up near-term performance standards that will make the choice of technology sort of fall into place by itself. And so if anything, I would just focus on setting that technology neutral performance standard and let the rest of it take care of itself.
Thank you. The next, Pak Kukuh.
Okay, thank you. Thank you, Pak Bubut. My closing statement is going to be that bioenergy, biofuel should be give a chance, and we need to be consistent on that one. Number one, because this is in line with the intention to reduce the emission, and we have it, and the technology is available. It's just a matter of consistency. Since 2006, we already have bioethanol. Now we have biodiesel. Let's do it that one. That's our local endowment. Then we can progress. And at the same time, we reduce the emission while we are moving forward with the alternative zero emission. Thank you very much.
Thank you, Pak Kukuh. Pak Rajesh, please, Mr. Rajesh.
Thank you. I think one of the things which I would like to highlight is it is very important that we plan not only bus, not only putting some charger in one depot. We need to think overall, including the charging chargers as well as the power needed for charging. Otherwise, if we don't plan to scale up in future, we may land up in a space constraint, as well as we will basically give lot of power quality issue to the grid, and then there will be a lot of penalties. So I think we need to think overall and then plan our charging strategies. Thank you.
Thank you, Mr. Rajesh. Pak Barman, 30 detik, silakan.
Ya, terima kasih Pak. Ya, anyway, we thank you for BPPT for being given the opportunity to convey we have developed at BPPT. BPPT is very open to collaborating in the manufacturing of a charging station, including development for the manufacture of charging station monitoring systems. We already have workshop that can be visited every time, and we also combine the charging station with alternative energy, and we are currently developing it with some partners. So I'm very happy if this is our chance to develop further with all our partners. Thank you very much. Yeah.
Thank you, Pak Barman, and thank you for all of speakers. I think we have many things from this discussion, and especially how we can start to develop the low carbon vehicle in relation to achieve the challenge of the decarbonizing mobility. And of course, we got many things from 5 speakers. And after this, I think that very important if Maskeei, or Indonesian Society for Conservation and Efficiency Energy, can follow up, bring it to the field, and also to discuss with the relevant government and propose something that's very important in relation to policy reform, and also to do something, especially on the technical situation, so we can implement the carbonizing mobility in Indonesia. Again, thank you very much, and we will close this. Thank you.